Hello scholars, welcome. Mr. Hinkle here. Today, let's go over very common foliated metamorphic rocks. So our objective is to do just that, define what is a foliated metamorphic rock by looking at foliations and then go over the common types. So metamorphism is one of our three types of rocks, and we identify rocks by how they form. And metamorphic rocks are rocks that have changed their form. So they start from either an igneous or sedimentary, or there's levels of metamorphic change that occurs. And underneath the impacts of heat and pressure, they change their form through the process of crystallization. Well, sometimes a planar fabric, a plane, is going to be a level surface, cuts through the rock. And we can identify these planar fabrics as foliations by the alignment of platy minerals or the creation of alternating light and dark bands, compositional banding. So foliations, as we see these beautiful foliated metamorphic rocks here, occur when there are differential stress. So where does the stress come from? Plate tectonics and the shifting of Earth's large tectonic plates over its surface. If the rocks have a composition with platy minerals, muscovite mica being a very common one, then it can give a streaked or striped appearance, also providing planes of weakness, which we could call rock cleavage, in which they will break, and we'll see the various rocks coming up. So let's look at, that's not a very good pen, increasing heat and increasing pressure to give us rocks of various metamorphic grade. The first rock that we're going to look at is slate. Slate, as we see here, has a really nice rock cleavage. Been used for a long time as roof shingles, for building materials. The thin layers resemble sedimentary beds, but this rock has been subject to heat and pressure. And slate often comes from the protolith, the original rock of shale, a fine-grained, clastic, sedimentary rock. So low-grade metamorphism, low heat, low pressure, slate. Now, this lecture is set up in terms of increasing metamorphic grade. Our next rock type being what is known as phyllite. I know it's a strange word, but that's how you say it. And phyllite is going to have an undulating, wavy pattern. It's going to have a sheen that reflects. Let's see if you can see that. Giving this silky appearance that, for lack of a better word, is called phylitic luster. But what we can see and what I want you to see is the difference between slate and phyllite. Slate is lower grade metamorphism. When you apply more heat, more pressure, you get more metamorphic change occurring to the protolith, which arises in different types of metamorphic rock. So phyllite is our second in this line. Now we have another fun word to say. This word is called schist. Trusted geologists, they know their schist when they see it. And this is a nice big rock where the muscovite mica grains, platy minerals, have all aligned in a foliation to give it this really nice sparkly. When you're walking in the outside and all of a sudden the rocks start to sparkle and dance underneath of your eyes, it's very common that you may be looking at the rock type schist. There's a lot of schist in the Sierra Nevadas where you had volcanic rocks intruding through the Sierra Nevada batholith, which then metamorphose the surrounding rocks, leaving us with the rock type schist. So the sparkly nature of schist is another textural fabric, textural foliation called schistosity. Now, keep applying heat and pressure, and what we end up with is another word that tests our ability to say fun geology words: nice. It's so nice, very nice. And what we get is a rock that has very distinct compositional banding. You can see the alternating light and dark bands here on a cut and polished surface. The bands have not only become alternating, but they're also in this wavy appearance, so they're no longer straight, indicating that this rock was buried deep in the heart of a mountain range, likely under the context of regional metamorphism at a continental collision convergent plate tectonic boundary. Now, if you've been studying geology long enough, these words are making sense, and we're able to locate and understand the geographic context through the lens of plate tectonics in order to give us specific rock types. A couple more. Metaconglomerate. So a conglomerate is a clastic sedimentary rock with rounded particles that are gravel or larger, and then when that rock is buried, the pebbles can be stretched, giving us a metaconglomerate. I don't have an example, but if you are watching this and you have an example, please reach out to me. I would love to have something to show students and to be able to use that as an example for these lectures. You can see the foliation here where the pebbles have been stretched. Last but not least, when you have rocks that are exposed to extremely high temperatures and pressures, at some point it's going to melt. You leave a bar of chocolate on the sidewalk in summer, and that chocolate bar, it melts. So rocks exposed to a certain amount of heat will eventually melt after changing their form. And according to Bowen's reaction series, different minerals are going to melt at different temperatures. So it would make sense that you have melting and metamorphism occurring side by side. And then if that whole thing cools, now you have a suite of metamorphic and igneous rocks that are together, giving us migmatite, partially melted gneiss, featuring both features of igneous and metamorphic rocks. Also don't have a sample of this, so calling out for any migmatite samples, please. Now, to conclude, a foliation is a planar fabric that is imprinted through the process of metamorphism, where a protolith will change its form into a metamorphic rock. And we have common metamorphic rocks with increasing grade that include slate, phyllite, schist, gneiss, migmatite, with some other shout-outs of metaconglomerate. This is not a comprehensive list, but a very good introduction to common foliated metamorphic rocks. Thank you so much.